Hi, and welcome to the next session of STM32 F4, uh, let's say crash course. Okay, so in this tutorial, which will be pretty short, I will talk through the process of finding the libraries and finding some basic guidelines for developing a firmware on your own. So basically, up to now, you were following me through some steps that I was taking to develop a firmware, for example, using USB or GPIO. But the thing is that how did I learn this and what are my resources? So in this session, we'll go through some resources that will help you in order to understand the process, and probably in future if you had a PCB, if you designed a PCB yourself, how can you change the codes to match your PCB properly? Okay, so let's go through the STM32Q uh, environment. I'm using the USB communication framework that we developed last session, so you can also use that. So I'm not sure if you have ever um, saw this or not. So basically, when we are using STM32Q, we are using some drivers and libraries. For example, HAL is one of the libraries. For example, HAL GPIO is another sub library for HAL. So basically, for each microcontroller family, for now we are working with the STM32 F4. But for example, if you want to design a simpler PCB using smaller, probably cheaper microcontroller, you can go for a STM32 F0 or F1. Okay, so for each of these microcontroller, you need to install the MCU package. So MCU package basically has the configuration and the abstraction layer, in parentheses HAL, that you want to use. For example, if you're using HAL GPIO toggle, it probably use different codes between F4 and F2. But since you're using that STM32 HAL library, it will basically abstract the hardware level, so you won't notice any difference when you're working with F4 and F1. You basically just write you basically just write HAL underline GPIO toggle pin, but underlay in let's say levels closer to the microcontroller hardware, those may differ in implementation, but you're not noticing because you're working with the abstract layer. So for making like for having a code that can run on basically most of STM32 microcontroller, you have to install MCU package for each microcontroller that you're using. And here you can see the different versions that are available here as MCU package. Okay, so for example, you can install this just by clicking here and clicking install. Okay, so these are called these in total, like all of them together, they called repository of an STM32Q. And when you install like a driver, it will basically install the driver on your PC, and it will be saved somewhere in your PC. Now, let's go through some steps to find where it's saved, because there are some useful sources there that you can use as a first step for any development that you want to do. For example, if you want to use I2C, if you want to use, I don't know, DAC, if you want to use DMA, you can just refer to those samples, take some notes from them, and then start to develop it yourself. Okay, so let's go through here the window menu here, and then preferences. Then from here, you have the STM32Q. Okay, so from here, you need to go through them to see the repository. Yeah, so this is the repository, and yeah, that's where my repository is. So if I go through this repository, basically I can find the examples that I was telling you. Okay, so let's open the file explorer, then C user Hamid STM32Q and repository, and then yeah, we installed F4 before, if you remember. So if you have these, you just need to extract it. So basically you can just click here and extract, or probably if you're using a different archive software, you might have different option here, but the thing is that you need to extract that, and then you will have this folder like that. But most probably you have it already because you have it installed. Okay, so here, if you come here, there are documentation, drivers, middlewares, and project. I will go through some of them. So documentation basically will give you some overall architecture overview, how this layer implemented. So you can see here, so we are working with this layer HAL. So you can install also middleware, you can install application level. I will show you later how. So this STM32Q has these features which you can use, and yeah, so here you have like a overall overview over the package itself. So it's talking about, okay, you have a discovery kit demonstration, then you have application, then you have libraries that you need to work with. This is the lowest level, and we are working in this level, which is the hardware abstraction layer. And then this hardware abstraction layer, which are the codes that we were using, for example, CDC underline transmit FS, or HAL underline GPIO toggle, or write pin, or whatever you use, it's in this layer. And then those abstraction layer, those codes will call some core drivers and low level drivers, okay? And those will be run on your microcontroller. So we have also some BSP drivers that we will use in this tutorial that we are going through. Okay, so that's you can just go through this and read for more details. I don't want to make this tutorial long, so just go through it. Maybe just have a look and see what feature it has. Okay, now let's go through some structure of the package. Okay, so you have drivers. Let's go through the drivers. So drivers will give you some code for some boards and some components. So for example, here you have this LIS3DSH or LIS302DL, which we will use. So we have these components on our board, and we'll use this driver. So this driver basically gives you the code that is required to drive those components, initialize them, and then use them. And it will save a lot of time for you if you were looking for a quick way to just have everything prepared. So it has some codes that will basically do everything you want for you, and you won't need to be worried for anything in that regard. Okay, so these are the components. So just let's go back. So we talked about documentation. So documentation will give you an overview of all packages that are available. And then drivers will give you, for example, we have BSP. For example, if you're looking for, I don't know, an LCD, you can basically buy it from Adafruit, and then this driver will help you to run that LCD or SD card even. Then the components, so we have like, I don't know, these are, for example, for driving the LCD, these are for NFC tags, these are some of them are for magnetometers. So we have different kind of components that you can basically use, and I will show you how to use them in the accelerometer session. Okay, so we have also BSP for STM32F4 discovery board. So if you open this, you will see that it has some basic codes for running on STM32F4. So basically, if you're using the discovery board, you can just take advantage of this library, these codes, and it will basically prepare everything for you. We'll go through it today, and you will see that. But if you have your own board, probably it would be useless for you to use this library, because they are specifically made for using STM32F4 discovery. But however, you can just take a look at it to see, for example, if they're using the accelerometer, how they managed it, how did they prepared the code for that. So that would be useful as well, but you cannot use it probably directly in your code. Okay. So what else we have? So we have different boards from STM32, from ST Microelectronic, basically. So you can, for example, buy one Nucleo board, and then you can just come here and then look for the codes that are related to that board. Okay. So let's go back. So we have CMSIS libraries, which we won't use probably here, and we have the STM32F4 HAL driver that we were already using. So for example, for GPIO, we have STM32F4XX GPIO. We should have it somewhere. Where is it? Yeah, it's here. So we have the codes for abstracted layer of STM32F4 GPIO. So you can see here, for example, dinit. We didn't work with dinit, but we worked with init, and there should be for read pin, write pin. So you see, these are the code. This is the abstract layer. Okay, so abstract layer, basically that's what you see, and that's what happened underneath that function. For example, here you can see it's working with some registers which you were probably not aware of, but here it will manage everything for you. But the thing is that knowing this is enough for most of the application. Okay, so this was the drivers. Now let's go through middlewares. Middlewares, you can use STM32 Audio. This is a library for preparing the STM32 for making sounds, receiving sounds. We have STMWin, which is a GUI library. If you're using a LCD for connecting for your board, you can basically use this STMWin. We have the USB device library, which you used already. So this was, if you remember, we were using the CDC. So the code for CDC is here. But these are the low level, so probably you won't use them much. But they are there. There is FreeRTOS, FATFS. So FATFS is if you connect a storage device like a flash memory or something, or even a SD card, you can use the FATFS library for handling the file operations on your SD microcontroller, SD card. We have FreeRTOS, which is a very simple and small real-time operation system, which you can use on your microcontroller. It's pretty easy to implement it using STM32Q. And yeah, we had LWIP, which is for handling the network things, embed TLS, which for network communication. Okay, so these were so in these things here until here, so the BSP was very useful. And then this middleware, probably you won't need them, because you just click on on tick box or something in STM32Cube, and they will be added into your project. But the pretty useful stuff are here in projects. So if you open the project, and let's say if you go to STM32F4 discovery, you have a couple of things here that are really useful. So let's go through the examples first. So in these examples, you can see there is ADC, BSP, DAC, DMA, flash, whatever you want. So there are some codes here. Let's go through the GPIO, for example, and then there is GPIO, for example, external interrupt. Okay, so if you have never used external interrupt, you can see the procedure that they took to enable an external interrupt. Okay, but it would be probably the basic one, because external interrupt is not a big deal. So you can see some codes here, HAL init, then external interrupt line config, probably a function somewhere. Where? Okay, where is it? Okay, it's here. So you can see what code they wrote. So basically, if you're using Cube, it will generate these codes for you. So you can see that there would be these codes for you uh, uh, already written by the STM32Q. Okay, so let's go through, for example, one. Let's say I2C. So for I2C, it has several options that you can take. So there is like communication with interrupt, communication with polling, it's communication with DMA. So they are really useful, and you can use them basically. Let's go for interrupt, and let's open the main.c. So yeah, here you can see. Okay, these are the code that STM32 will generate for you, but here this code are really useful. So if you don't know how to use this HAL I2C master transmit IT, you can just take a look here and get here, and then you will have whatever you need. So these are the codes that I basically use every time that I get stuck in somewhere. And for example, if I don't know which function should I use first and which function should follow, so I'll take a look at this code. So these examples things here are really useful. And the thing is that as we are using the HAL abstraction layer, so basically you can take a look at whatever example you want in all the repositories. So for example, if you have F1 package, you can just go through F1 and then go through the examples and take a look at the codes there, and it will be compatible with F4. Because, there are some, so for example, you can see here, we have a couple of stuff, but if you go, for example, to another board, let's say this one. Okay, this is almost same. Let's go for Nucleo. Yeah, you see it has less, so I can use the other examples for other boards and just change it to be compatible with my board. Let's see if we can find more. Yeah, I think this has a bit more, so you can use the example here. So you see the example are not identical, so you can have like, let's say 20 example for one board and then 2 example for another board. But the thing is that since you are using abstraction layer, you can use whatever code you find anywhere in these codes, or even in other packages for, let's say, F1, F0, or even F7 board. You can use them as they are there on your microcontroller. The only thing is that you need to make sure that the peripheral that you're using is available on your microcontroller. Okay, so for example, if you're using DMA2D, okay, DMA2D is basically available on some F4 series and F7 series and H7 series. So it won't be available on F1, and probably you will already notice that while you're developing the board. But anyway, the only thing is that they should be available on your board. So I think that was all. Oh no, sorry, we didn't. So you see, for example, here, just a good one. So you see, it has a lot of examples for the STM32. Oh, this is a totally different series. I never looked through the code, but it should be the same. So let's just have a quick look. Oh, why it's not? Okay, let's have a quick look to see if they are using the same abstraction layer as others. It should be the same. Yeah, they're using the same. So basically, even you can use this one, but I will suggest I would suggest you to use the other one. So these are the other one. And okay, so let's go back to the projects, and then there would be some application as well. So application is basically providing you some full application of a functionality. So for example, they are using GPIO, I don't know, I2C and SPI at the same time. So they are application. They are not a specific, let's say, SPI example. They are a combination of several examples, but they are usually they are so limited. So you can see here, just there are three examples. So for example for FATFS, let's just take a quick look at it. For USB disk, okay, so you see it's just the application basically for, probably it's writing something, yeah, it's writing a text file into a USB device. So it will be really useful, really useful. So, but I don't know why there are not clear explanation of these useful things in STM website. I just found them like by chance, but that's really useful, and I think it will be very useful for you. So that's all. So these are also some utilities that you can use. For example, yeah, it's for SSL server for running on your PC, and then some phones for using on LCD drivers. Yeah, you can take a look at them. I honestly I never use them, but you can also take a look at them. It would be probably useful. So that's where I start. For example, if I encounter a SPI problem, or if I found let's say a component that I can have it here, okay, I just go through it and I just take a look at the code here, and then I get some ideas of how to implement it. And in case that you didn't find a library here, basically what I do is that I just go through as let's say I want to use MPU 9250 component. So I just search here for driver, driver, and then you should find something for it, and then probably it's for another microcontroller, and then I just go through the source, and then I found this is the library basically. So I just take a look at the library, and then I try to follow the same thing that they did in my code, and I will make my own library. So that's the another step that I take usually for writing firmwares on STM32 microcontroller. So yeah, that was the all I could say. And of course you need to always have user manuals for STM32 and for the component that you're using handy. So in case you need to check something, in case you need to read about a specific event, you can just go and take a look at it. So that was all for this session. So basically it was a general overview of how I start writing some codes for my board, and I hope it would be useful for you as well. Okay, see you in the next one.